Everyone grows up believing the same simple story. The sun is a giant ball of fire, burning endlessly in the sky. It seems obvious. Fire gives off heat and light. The sun gives off heat and light. The conclusion feels natural. But that story, familiar and comforting as it is wrong. The sun is not burning. It has never burned. Not once in its 5 billion year existence. And when you truly understand what is happening 93 million miles above your head at this very moment, the sky will never look ordinary again. For most of human history, the sun was mystery wrapped in divinity. The ancient Egyptians called it Ra and aligned their temples to its rising. The Greeks tried to reason it into something earthly. Anaxagoras dared to suggest it was not a god, but a red-hot stone larger than the Peloponnese, and he was exiled for it. Aristotle imagined it made of a fifth element, something unlike anything found on Earth. For thousands of years, brilliant minds circled the same haunting question: what is that thing, and why does it not go out? By the 19th century, science had sharpened the mystery rather than solved it. Physicists could calculate how much energy the sun releases every second. The number was staggering beyond intuition. In a single second, the sun emits more energy than all of human civilization has produced throughout its entire history. Every second, without pause, for billions of years. Hermann von Helmholtz proposed that gravity slowly contracting the sun could power its heat. It was elegant, but it failed the math. Such contraction could only sustain the sun for about 20 million years. Yet geologists were uncovering rocks far older than that. The sun's endurance was a scandal in the equations of the time. The problem begins with a metaphor we have never fully abandoned. We picture the sun as a campfire in the sky. Fire is our oldest companion. It warms us, feeds us, protects us. So when our ancestors looked upward and saw a blazing light, they named it what they knew. It burns. But combustion is a chemical process. It rearranges electrons around atomic nuclei. It requires fuel, and fuel runs out. If the sun were made of coal and burning in oxygen, it would exhaust itself in about 10,000 years. 10,000. Instead, it has shown for 5 billion. The truth lies deeper than chemistry, deeper than fire, deeper than anything our ancestors could have imagined. It lies inside the atom. At the core of the sun, temperatures reach about 15 million degrees Celsius. The pressure is 250 billion times that of Earth's atmosphere. Under these extreme conditions, hydrogen nuclei move with extraordinary speed and density. Normally, positively charged nuclei repel one another. This electromagnetic repulsion is called the Coulomb barrier. On Earth, it is insurmountable. Hydrogen atoms can collide endlessly without fusing, but in the sun's core, something strange and beautiful happens. Quantum tunneling allows particles to pass through barriers they classically should not cross. When two hydrogen nuclei come close enough, the strong nuclear force binds them together. They fuse. Through a chain of reactions, for hydrogen nuclei combine to form one helium nucleus. But the helium nucleus weighs slightly less than the 4 hydrogens that formed it. About 0.7% of the mass vanishes. It does not disappear into nothingness. It becomes energy, described by the most famous equation ever written, E equals mc squared. A tiny amount of mass multiplied by the square of the speed of light yields an immense release of energy. The sun converts about 600 million tons of hydrogen into helium every second. 4 million tons of mass are transformed directly into pure energy every second. This is nuclear fusion, not burning, not combustion. Fusion rearranges the nucleus itself. It is a deeper transformation than fire could ever achieve. The light produced in the sun's core does not rush outward instantly. It can take roughly 100,000 years for a photon to random walk its way to the surface, bouncing, absorbed, re-emitted countless times within the dense solar plasma. Only then does it escape into space, traveling 8 minutes across the vacuum before touching your skin. The warmth you feel today may have begun its journey long before our species painted caves or spoke its first words. The sunlight on your face is ancient beyond imagination. Every atom of carbon in your body, every atom of oxygen in your lungs, every atom of iron in your blood was forged in the hearts of stars. Massive stars lived and died before our sun was born, creating the heavier elements and scattering them into space. From that enriched cosmic dust, our solar system formed. We are not merely beneath the stars. We are made of them. And the sun continues this intimacy. Its photons strike leaves, drive photosynthesis, build sugars, grow plants, feed animals, fuel your muscles and your thoughts. Every movement you make is solar energy transformed. You are, in a very literal sense, starlight that has learned to think. Our sun is only one star among 200 to 400 billion in the Milky Way galaxy, and there are perhaps 2 trillion galaxies in the observable universe, each star performing its own quiet fusion, converting mass into light. The nearest star beyond our sun, Proxima Centauri, is over 4 light-years away. The Andromeda Galaxy lies 2.5 million light-years distant. When you look at it, you see light that began its journey long before modern humans existed. The universe is vast beyond language, and yet here we are, small and brief, comprehending it. The sun does not go out because it is not burning. Burning is consumption at the surface of matter. Fusion is transformation at its core. The sun is halfway through its life, with roughly 5 billion years of hydrogen left to fuse. It is not a raging explosion sustained by brute force. At any given moment, the chance of any specific pair of hydrogen nuclei fusing is incredibly small. The sun's power comes from patience, from the steady whisper of countless improbable events sustained over billions of years. For this brief moment in cosmic history, the sun shines on us. It has done so since long before humanity, and will continue long after every monument we have built has turned to dust. The real question was never why the sun does not go out. The deeper question is what it means that in this narrow window of time, it shines on beings capable of wondering about it at all. The universe is 13.8 billion years old. You are here for perhaps 80 of them. And above you, not a fire, but a star, quietly turns mass into light. Look up, and if you truly let that settle into your bones, something subtle begins to shift inside you, because the story of the sun is not only a story about physics, it is a story about balance, about tension, about forces that in any other context would tear things apart. Yet here creates stability for billions of years the sun exists, because 2 immense powers are locked in a perfect embrace: gravity, pulling everything inward, trying endlessly to collapse the star into itself, and nuclear fusion pushing outward, releasing energy that resists, that collapse. If gravity were slightly stronger, the sun would compress more tightly, its core temperature would rise, fusion would accelerate, and the star would burn through its fuel more quickly. If gravity were weaker, the core would cool, fusion would slow, and the outward pressure would drop, allowing further contraction until balance was restored. This dynamic equilibrium is called hydrostatic equilibrium, but the name hardly captures the poetry of it. Sun survives because of a continuous negotiation between inward fall and outward light, a cosmic tension held steady for 5 billion years. Imagine that scale of stability, not rigidity, not frozen perfection, but living balance, constantly adjusting, constantly recalibrating. Every second gravity presses inward, every second fusion answers outward. And in that dialogue, stars are born, stars endure, and eventually stars die. Because the sun is not eternal, no star is. Immortality is not written into the laws of physics. It is only written into myth. For another 5 billion years, the sun will continue fusing hydrogen into helium, in its core slowly building up helium ash. As the hydrogen supply diminishes, the core will contract under gravity, heating further. While the outer layers expand, the sun will swell into a red giant, engulfing the inner planets. Perhaps even Earth, its surface will cool and redden while its interior burns. Hotter and more furiously, eventually, it will shed its outer layers into space, forming a glowing planetary nebula, leaving behind a dense white dwarf roughly the size of Earth, yet containing about half the sun's current mass, a stellar ember cooling quietly over trillions of years. This is not catastrophe. It is transformation, the same process that created you will someday unmake the world you know, and yet from that ending new beginnings will arise, because the material expelled from dying stars enriches interstellar space with heavier elements: carbon, oxygen, silicon. Iron, the building blocks of planets and life. Without stellar death, there would be no chemistry complex enough for biology. Without collapse, there would be no creation. The universe recycles itself through fire that is not fire, through fusion that builds and explosions that scatter. So when you look at the sun, you are witnessing not permanence, but process, a chapter in a larger unfolding story that began when the universe itself was young and unimaginably hot about 13.8 billion years ago. The universe expanded from an initial state of extreme density and temperature. In its first few minutes, only the lightest elements formed, mostly hydrogen, with a little helium and traces of lithium. There was no carbon, no oxygen, no nitrogen, no iron. The cosmos was simple, almost sterile. Stars were required to complicated gravity, gathered vast clouds of hydrogen and helium, pulling them together until their cores grew hot enough for fusion. The first stars ignited, bringing light into a universe that had previously known only darkness, and those first stars were likely enormous, far more massive than our sun. They lived fast and died young, exploding as supernovae and forging in their cores the heavier elements that would later become planets, oceans, atmospheres, bones, blood. Thought you are therefore a late arrival. In a very old drama, hydrogen, born in the first moments of the cosmos, drifted for hundreds of millions of years before gravity sculpted it into stars. Those stars lived, died, seeded space with complexity, and from that enriched matter our solar system formed about 4.6 billion years ago. The sun ignited from a collapsing molecular cloud, and around it a disk of gas and dust flattened and coalesced into planets, comets, asteroids. Earth formed. In that disk a molten sphere, gradually cooling, forming crust, oceans, atmosphere, and eventually life. The sun's steady output provided the stable energy flow necessary for chemistry to experiment. For billions of years life emerged, not because the sun blazed unpredictably, but because it shone reliably. Stability is underrated in cosmic storytelling. We often focus on explosions, supernovae, collisions, black holes. Yet the quiet constancy of a main sequence star is what allows biology to unfold. Photosynthesis began in ancient microbes capturing sunlight to split water, releasing oxygen as waste. Over time, oxygen accumulated in the atmosphere, enabling more complex life forms. Every breath you take depends on that ancient solar powered innovation. Forests, oceans, weather patterns, climate, all are driven by the sun's energy. Differential heating between equator and poles drives winds and currents. Evaporation lifts water into clouds which fall again as rain. The hydrological cycle is sunlight made visible. The food chain is sunlight metabolized. Ecosystems are sunlight arranged into intricate networks of exchange. Even fossil fuels, ancient sunlight captured by prehistoric plants and stored over hundreds of millions of years, represent delayed solar income. When you flip a switch and electricity flows, part of that energy may be sunlight from the Carboniferous period released in an instant. The sun, therefore, is not only above you, it is within every system that sustains you. Yet despite its power, the sun is an average star, neither unusually large nor unusually small, neither exceptionally bright nor dim. It belongs to the spectral class G2VN. Ordinary main sequence star in the outer regions of a spiral galaxy. There is humility in that fact. The conditions that allow life here do not require cosmic extravagance. They require balance, distance, temperature, time. Earth orbits within what astronomers call the habitable zone, where liquid water can persist, not too close to boil away, not too far to freeze permanently. A narrow band in space defined by energy flux and atmospheric properties. And yet, even that zone is not fixed. As the sun slowly brightens over billions of years, the habitable zone shifts outward. In perhaps 1 billion years, Earth may become too warm for oceans to remain stable. Long before the sun becomes a red giant, climate is not static. Even on geological timescales, the future of life here is finite, and that finitude sharpens the present moment. Because rarity enhances value, consider the improbability layered upon improbability. Quantum tunneling events in the sun's core, converting a tiny fraction of mass into energy. Photons wandering for millennia before escaping 8-minute journeys Across space, chlorophyll molecules tuned by evolution to absorb specific wavelengths, chemical pathways, assembling sugar cells, organizing into tissues, nervous systems, evolving consciousness, arising capable of abstract thought, capable of asking, why does the sun shine? Each step contingent upon prior steps, none guaranteed. From the perspective of fundamental physics, the universe did not promise to produce minds it merely followed its equations, yet here you are, a temporary arrangement of atoms, forged in stars, animated by solar energy, contemplating the nuclear processes that sustain your existence. This feedback loop, matter reflecting upon matter, is one of the most astonishing outcomes of cosmic evolution. The sun is not aware of you. It fuses hydrogen, indifferent to planet's life or thought. And yet through you, the universe achieves a kind of self-awareness, hydrogen organized into stars, stars synthesized heavier elements. Those elements assembled into planets. Chemistry became biology. Biology became cognition, and cognition now models stellar interiors, writes equations, launches spacecraft, measures neutrino flux from the solar core, confirming in detectors deep underground that fusion is indeed occurring. The sun sends not only photons, but neutrinos, ghostly particles that pass through Earth almost unhindered. Billions pass through your body each second. Without interaction, they are direct messengers from the core, arriving in minutes rather than millennia, providing confirmation of processes we once could only theorize about. Our understanding of the sun is therefore not poetic speculation, but experimentally verified physics. And still the poetry remains, because knowledge does not diminish wonder, it refines it. When you realize the sun is not a raging inferno, but a finely tuned fusion reactor balanced between gravity and radiation pressure. When you realize its light is ancient by the time it reaches you, when you realize your own metabolism is powered by that light. The boundary between self and cosmos softens. You are not standing apart from the universe, observing it from a safe distance. You are an expression of it, a localized pattern in a vast energetic flow. And that perspective carries implications beyond astronomy. It reframes fragility and resilience. The sun appears unchanging day to day, yet it is in constant flux. Granules boil across its surface, magnetic fields twist and snap, producing solar flares and coronal mass ejections, occasionally hurling charged particles toward Earth, which can disrupt satellites and power grids. Our technological civilization exists within the sun's extended atmosphere, vulnerable to its moods. Even average stars possess dynamism that reminds us stability is dynamic, not static. The sun's magnetic cycle reverses approximately every 11 years. Sunspots wax and wane space, weather ebbs and flows. We monitor these cycles because our modern infrastructure depends on anticipating them. Again, the dialogue between star and planet continues, shaping conditions for life and technology alike. And still the deeper arc remains billions of years. Hence the sun will exhaust its core hydrogen contract, ignite helium, fuse it into carbon and oxygen, swell, shed layers, and fade. The white dwarf remnant will radiate away residual heat over unimaginable spans of time, perhaps trillions of years, far longer than the current age of the universe. In that distant future, no human memory will persist, no monument, no language, no archive. Unless intelligence spreads beyond Earth, carrying knowledge elsewhere, the atoms that compose you will long since have been recycled into other forms, perhaps locked in rock, perhaps drifting in interstellar space, perhaps incorporated into future organisms around other stars. The sun's story will end quietly, not with a violent supernova, but with a gradual dimming, yet even that ending participates in the grand cycle. Matter return to the galaxy, available for new stars, new worlds, new possibilities. So when you step outside at dawn or watch sunset staining clouds gold, you are witnessing the visible signature of nuclear fusion balanced against gravity, a process that began before Earth formed and will continue long after human history concludes. The warmth on your skin is mass converted to energy in a stellar core. The food on your table is structured sunlight. The thoughts in your mind are patterns sustained by metabolic pathways, ultimately powered by that same star. And for this narrow window of cosmic time, gravity and fusion remain in equilibrium, allowing oceans to shimmer, forests to breathe, minds to question. The universe is vast, almost incomprehensibly so, yet its laws are intimate, operating in the heart of a star and in the cells of your body. With equal consistency, the sun does not burn, it transforms, and in doing so it makes transformation elsewhere possible, including within you are. Temporary, yes, but you are also extraordinary, a configuration of star. Forged matter animated by ancient light, capable of tracing your origins back through planetary formation, stellar evolution, nucleosynthesis, all the way to the first seconds after the beginning of cosmic expansion. The next time someone says the sun is just a ball of fire, you may smile, not in superiority, but in quiet appreciation of how much deeper the truth runs, because above you at this very moment gravity pulls. Inward fusion presses outward, neutrinos stream, photons wander, magnetic fields coil and unwind, and in that sustained balance, mass becomes light, light becomes life, and life becomes awareness, contemplating the star that made it. Look up, not out of habit, but out of recognition, for in that brilliant disk is both your distant past and your distant future, written in hydrogen and helium and gravity and quantum tunneling and equations, and in awe. And for a fleeting span of decades, you stand beneath it, aware that it shines at all.